Okay, hi everybody. Can you hear me there? Can you hear me?
Yeah.
Okay, now I made an announcement. I have all the exams graded. Basically, the top score with the curve is about 97 points. Many of you did okay. Some didn't do that well, but because it's only about 15% of the grade because we have 4 exams together, and such like that, 15, 16% of the grade. If you do better on the second, third, and fourth exam in the final, you'll pull your grade up, and I'm sure you'll do just fine. But based on what I've talked about with the other faculty, this class is very much in line with the other groups. So just come see me, and I'll be glad to go over things. I will be turning the exams back to you tomorrow, and also we will have a quiz tomorrow afternoon. During class, the last half of class will be the quiz, and it will be graded. I changed my mind regarding that. And basically, this is an opportunity to show that you understand how to do the stoichiometry, basic questions, working through a problem. So I encourage you to work on that over this evening to just prepare for that quiz. There won't be any surprises. It's going to be what I covered up through the end of chapter 3 before and such. Yes. Hello, I'm sorry we got disconnected again. I was just announcing that basically going over that we will have a quiz tomorrow. I'm going to try and arrange for those of you doing distance, if you can come at 11 o'clock for about half an hour tomorrow. And if you can't come at 11 o'clock, please arrange with me separately, and you can take a quiz another time tomorrow afternoon, or before class tomorrow. So just I'll send out the announcement this afternoon. But basically, we will be having a quiz on that material that we've covered. Any questions of those of you who are distant? Any questions? Okay, let's start off where I left off. Okay. Okay, I'm going to share the screen with you folks now. I'm going to share the screen now. Can you all see the slide? Everybody see it? Can everybody see the slide?
Yeah.
Okay, good. So let's continue where I left off. Yes. Oh, what happened? Oh, okay. Got it now. Okay, you can see that now. Good. Okay, very good. So let's continue where we left off. There's a little things. Basically, solving mass stoichiometry problems requires all the steps of the mole ratio method. And again, please keep the visuals in mind. It's like going like that across the thing. You go one step at a time. You can do it using the periodic table. I'll always have a periodic table. And my quiz will be going tomorrow through a sample problem, one step at a time. You solve the first part, you solve the second, you solve the end, and then you do it, and then we'll have a limiting reacted question at the end. Okay, so I want you to see the logic here, what's going on. And if you practice this, this will get you ready for the next exam. And many of you, I know, will want to do and can do better on the next exam. So please keep that in mind. Okay, now first you convert the grams to moles. Then the mole ratio is used to determine the moles of desired substance. Where do you get that from? The balanced equation, correct. So if you have a problem, you start with balancing the equation. You've got to start with the balancing of the equation first. Okay, then the moles of the desired substance are converted to the mass of the desired substance. So essentially here, this is where you go from reactants to products. That's the top here, okay? Then this is the third part. So this is 2, this is 3, this is 1. Okay, so let's start with this problem. Sure. These are on the slides, so just if you understand, I did say them, and I will say them again for you. Yes. This is Hein. It's in the Hein thing, chapter 9. And if you want to see the text, refer to that book for chapter 9. I recommend you do the problems in there first. Okay, and then move to chapter 3 of ours. Okay, so you ready? You ready for this? Okay, so let's start with this problem. They've already balanced it for you, right? So what's the first step? Grams to moles. So basically you start with converting the moles of hydrogen, grams to hydrogen. So let's go through one thing. Convert 112 grams of hydrogen to moles. Okay, so you start with that. You look at the periodic table. You should have hydrogen sort of memorized by now, but basically 2 times 1 is 1. You'll always have that periodic table with you, okay? Tomorrow for the quiz, make sure you bring your calculator. You won't be able to do the quiz without the calculator, okay? Then you do the next thing. Now, this, he has a good method, but I encourage you to use this one, okay? And then go across the barrier with a continued line like this, okay? So basically, I like to do it that way. And you have this be the other one there, and then this is the up, this is the down, and you're done, okay? So basically, I highly recommend you do that method, okay? But whatever works for you. If you like the book method better, that's good too, okay? So now you have 54 moles of hydrogen. Can you stop at that point? Yes, if you're asked the problem, how many moles of hydrogen are you doing? So essentially, that's what we first learned at the end of chapter 2, okay? So now calculate the moles by the mole ratio method. This is the top of it. 55.4 moles of hydrogen. Now you have the mole ratios. Where did those numbers come from? From the equation, very good. You got the 2 moles of ammonia require 3 moles of hydrogen. Now, I recommend you keep the verbiage I used in mind. I said 2 moles of ammonia require 3 moles of hydrogen. So kind of have that line be require. It'll help you keep in mind what reaction is taking place. Okay, so now you have 36.9 moles of ammonia. What's the next step? Convert back to grams again, okay? So now you convert it back to grams again. Moles to grams, you have 36.9 moles of ammonia. You go back to grams now, and that gives you the amount of product, okay? Now, you started with 112 grams of hydrogen. You end up with 629 grams of ammonia. How many grams of nitrogen reacted with it? Well, no, 6. The amount of grams that react with it are the 629 minus 112. So 629 minus 112 is equal to 517. That's the number of grams of nitrogen, okay? Because the mass balance has to be the same on both sides. You got 629 grams of product, and you got to have the equal amount of the 517 grams of nitrogen, and then essentially you have the total there. So basically they work together regarding that, okay? So the continuous method, okay? And this is what I like using, okay? You go to grams to moles there, okay? Continue there.
Where did you get that?
Sorry?
I got it, sorry.
That's from the problem, that's all.
Yeah.
Okay, so the continuous method, this is what I like. Whatever works for you. If you want to do stop and continue, fine. But that's what you put down your work so you can see it. On your paper, when you're working the problems, write them out. Don't just use your calculator to kind of remember the numbers, but just write it out there for yourself so you get the hang of it. Okay, now limiting reactant and yield calculations. This is the last part of chapter 3, but it goes over more in depth in chapter 9 of Hein. So I highly recommend you look at that first. Okay, limiting reactant. It's one of the reactants of a chemical equation, reaction. And again, if it helps you, remember my hot dog and bun example. If you have 4 hot dogs and 2 buns, what's the limiting reactant? The buns, yes, very good, okay? The amount of it present is insufficient to react with the amount of other reactants that are present. The limiting reactant limits the amount of product that can be formed. And so the other stuff that's left over is unreacted. It stays unreacted. You can't manufacture the other element out of nothing. Now, if you have 8 wheels and 4 frames, you could make and 3. Okay, I've got to fix it again, folks. We lost you. Okay, can all of you see the screen again? Can all of you see the screen again?
Yes, I can see it.
Okay, good. Okay, so what is the limiting reactant with this situation? The petals, yes, because you have 3 of them, okay? So basically it goes from the reactants to the products. Okay, now this one, hydrogen plus chlorine goes to hydrochloric acid, essentially there before reaction and after reaction. This is what they have related to that. 4 molecules can form 8 molecules of HCl. And basically this goes a little bit more into detail, what I showed, and then they got excess of one of them. So basically, you'll have some excess related to it. So this is just another example. Steps determine the limiting reactant. Calculate the amount of product formed from each reactant. Okay, that's like doing the same problem twice. Okay. I'm sorry, I have postnasal drip. It's annoying with allergies and such like that. This happens. But in any case, you calculate the amount of product from each reactant, determining which reactant is limiting. The amount that gives the least amount of product is limiting reactant. The other reactant is an excess. And then calculate the amount of the other reactant required to react with it, and then subtract it from the starting quantity. This gives the amount of substances unreacted. Examples. How many moles of HCl can be produced by reacting 4 moles of hydrogen with 3.5 moles of chlorine? Now let's look at this obviously. You have 4 moles here. You have 4 moles here and 3.5, oops. Be logical about it. You have 4 moles here and you have 3.5 there. What are you short? Yeah, 0.5 of chlorine. So you can kind of sometimes answer the question just by inspecting it. Okay, so basically you start off with the amounts of each reactant. You determine how many moles of HCl you can get. The second one, that determines, now which one is less? Huh? The chlorine, that makes less product. Okay, so basically this is the limiting reactant now. Okay, but we kind of we could get that by inspection. Is it really any difference if you say you have 8 grams of hydrogen and 35 grams of chlorine? Is there really any different a problem? No, you just got to convert grams to moles to answer the same question, okay? So basically, it's just a matter of adding one additional step going from grams to moles, okay? So the limiting reactant is the one that gives you less product. Okay, now how many moles of silver bromide can be formed when you solutions containing 50 grams of magnesium bromide and 100 grams of silver nitrate are mixed together? How many grams of the excess reactant remain unreacted? So what's the first thing we have to do? They've already done the first step for you. Balance the equation. Yes, very good. So now we go 50 grams of magnesium bromide. You go to the periodic table and figure out what the molar mass is. And I'm not going to mess it up regarding each of that. So essentially what we'll do now, the grams of reactant to moles to grams. So again, they're going like this, 1, 2, 3, like that. You see that? The grams of reactant, then the product, okay? And essentially it went the same thing. So you start off with 50 grams, you put in the molar mass of the magnesium bromide. What cancels? The grams of magnesium bromide. You now have moles, okay? The next dump is 2 moles of a silver bromide require 1 mole of magnesium bromide, okay? And then you convert it into grams and then do the math at the end. There's 102 grams of product. What do you notice about the total of your ingredients? At the top part, what's the total mass of the ingredients? Huh? 150, right? And you get 102 grams of product. So how much excess do you have left over? 48, yes. And of what? Well, you figure out what the limiting reactant is to figure out which one it is. And basically it's going by that. That's the next step. You can figure out what it is. So next one, you put in 100 grams of silver nitrate, convert to moles, go to moles again, do the other one, and you get 110.5 grams of silver bromide. What is a limiting reactant? The magnesium bromide is a limiting reactant. So that's what's left over. That's what you have excess, sorry, no, you have excess of the silver nitrate left over. Sorry, I lost you. Are there any questions of those that kind of got missed, that missed this, people? I'm sorry, I lost you again. Are any questions on this for those of you I lost? Any questions? Okay, basically what I was saying, because the lesser product one, essentially you have the 102 grams. This is the one you have less product. This is the one you have less product there. That's the limiting reactant. That gives you less material. So limiting reactant is magnesium bromide because it gives you less product, okay? And then you can figure out how many grams of each you have, okay? Now, how many grams of the excess reactant left over? You figure out to calculate the number of grams of silver nitrate that will react with it there, or you can just subtract. Now that you know what the limiting reactant, you can subtract the numbers together because the numbers will add up. But let's go through this process. The grams of magnesium bromide to moles to grams again. So again, you use the math to do that. That gives you 92.3 grams of silver nitrate. Yes?
Where did you get 50 grams of magnesium bromide?
That was in the 50 grams, that's in the original problem right there.
Didn't we already do it? Like we found out that
Yeah, but he goes to some additional steps because basically what I did, at first you have 150 grams. I did it a little easier. You have 150 grams of each. You just need to figure out what the amount of product it is, and minus 102, that'll give you 48 grams of material. And what is the limiting reactant? The magnesium bromide is limiting reactant, so that must mean you have the silver nitrate left over. That's kind of a shortcut. Yes.
Where is the 150?
That's the total of 50 plus 100,
Okay, so why are you subtracting the,
because that's how much product you get with the limiting reactant right here.
so what are you trying to find?
The amount of excess reactant left over. Okay, the excess is the silver nitrate, right? Because you got two things in there. If you got a limiting reactant, which is like the hot dogs, okay, the excess will be the buns, okay? So basically you're just using mass balance to determine that. So that's sort of a shortcut, but it makes it a little understandable instead of going to additional steps like he does, okay? But it's just us chemists doing it different, yes.
So the 48 grams of the silver nitrate is the excess?
Yeah,
common excess?
yeah, that's left over, and you can stop there at that point.
You
But
don't do all the other steps like that?
well, if you want to, the whole point of this is calculate the grams of unreacted. To do that, you can do that. You can do that if you want to do it and then go through the additional steps, but I don't see a point of doing it. I always understood it by saying the mass of one side equals the mass of the other. You can't get more mass than isn't there, okay? You can't take 50 grams of one thing and 100 grams of the other reactant and get 300 grams of the product on the other side. It doesn't work, okay? So basically, that's just a matter of logic. Yes.
Can you go back to the other solve?
Okay.
Okay, so all you have to do to find like how much the excess is you just take the total mass of
Right.
the two reactants.
50 plus 100. That's the total mass.
Okay, and you just subtract.
That's
that
150 minus 102. Okay, that's the amount of product you got, right? The lower number. Okay, so basically the other thing is left over. That's all.
Okay, then you subtract
Because what's in excess is the silver nitrate. This says this is an excess. This is an excess. So that's obviously going to be the other material. It just simplifies it and helps. It's a little more logical, but the author for these adds extra steps with it. If you find this is easier, by all means use it, but I like my method better. Okay, so basically the conversions there, the number of grams of unreacted silver nitrate, figure out the number of grams it will react with 50 grams of magnesium bromide. And basically this is using the same side of the reactant. Okay, so essentially you have the 2 moles, this ratio 2 moles to 1. You're essentially staying on one side of the thing, going back the other way. You're not going across to the products. Okay, and then you get that in there. That's 92.3 grams of silver nitrate is required. So then the difference is just the amount of magnesium bromide that remains is 7.7 grams of silver nitrate there. Okay, so basically the key thing is you've got to have everything total up correctly.
That was the number you got for the last slide.
Well, that's why the other way is less confusing. Okay, here, if you have 50 grams of this and then 100 grams of the other, and then you have this as the product, and then the silver nitrate's left over, it's got to equal the difference between the two. Okay? Okay, 50 plus 100. These are the reactants, correct?
yes,
Okay, on the other side, it gives 102 grams of the product of the silver bromide. That used up everything that was in, that used up all the magnesium bromide that's left over, correct? So basically the only thing that's left over that did not react is what? The silver nitrate is left over. Silver nitrate, and that will be a total of 48 grams of silver nitrate left over. Yes.
But then how does that number relate 48 grams on that side.
Well,
So where does that come into play here?
Well, that's because it gets confusing because on the other side, that's how much is required to react magnesium bromide. But that's not the point. That's not the point of the reaction. So essentially that's how much to react to 50 grams of magnesium bromide there. And again, I don't know the rationale with it. To me, it doesn't make any sense because the mass balance doesn't work out.
So
I'm-
you put it on our quiz or on a test, you wouldn't want us really.
No, in a way, I'd recommend you just kind of not go in that direction because it's all about the mass balances. Okay, if you got excess of one, it's going to sit there and not react at all.
So basically, on the quiz, we'll go up until the last slide, or the slide before, where you just have the 102 and 110.5.
Correct, because
That's as far as we'll go.
yeah, because you got 150 grams of reactants on the left, right? You're not getting any more from that. And you have 102 grams of the silver bromide.
Dr. Douglas, I think you're muted. We can't hear you.
Okay, as I was saying, this is the place to end because essentially the whole point is you have 50 plus 100 on one side, correct? And then you've got a product on the other side, which is 102. What else is going to be there?
48, which I get.
Which
but
is
then
48.
Wouldn't that be a part of what you spoke? Or what was the imbalance?
It'll be unbalanced. It's just not, it doesn't react at all. It just stays in solution because these are both in solution there. It's two solutions of them.
Well, what do we do with that value? What do we do with the 48?
That's just the answer to how many grams of what's left over, 48 grams. But this is a confusing thing because that slide he had then in there, but I don't know why the guy who did it added the extra step. To me, it's kind of pointless because essentially, as I showed you, what is he doing here with this? Where is he staying on the reaction? He's just going grams to moles to here, to moles to that, going back to grams. Again, it's staying on one side of the reaction. Essentially, he's just staying on one side of the reaction to get the amount of grams of silver nitrate that reacts with it. And again, it's confusing, and I don't want to confuse you. That's why I crossed it off. Okay? So if it's helpful, ignore the slide. I can delete the slide if that's helpful, but I wanted you to understand how even people make up these things, make mistakes, because it's a logical bend there. Okay, because the masses on both sides have to equal each other. If you go through the thing there to get there, the amount of magnesium bromide that remains, okay, but the magnesium bromide, as I said in the previous reaction, that's the limiting reactant, right? What does that say? What does that say is a limiting reactant? No. What is that? What's limiting reactant? The magnesium bromide, because that gives left product, right? Okay, so that just proves the next problem is wrong, because essentially what they're saying here is what remains is The amount of magnesium that remains is, yeah, they're saying it's excess, but it's not in this problem. So that's what I'm saying. The author of these slides missed the logic himself. He made an error. This is not my error. I just want you to see what everybody errors you will make as you learn this stuff. That's why it's important to keep in mind the mass balances. The mass balances help me to see where the error was. Okay? And when I've taught this stuff, I haven't gone this far in the slides because I made the point regarding it. I'm just going today with it just to help you understand going through it. I had forgotten this was in the slides, but it's useful just to help illustrate the whole point of what mistakes you can make as a student. Now, I've been teaching chemistry since 1991 and as part of labs since 1979. Do I make mistakes in my own problems when I'm working them out? Yes. The reason I could teach it is I make them a lot less frequently. Okay, so again, it doesn't mean I'm perfect in my own logical think because I'm human too. I just got very good at it and I make less mistakes. But the point is, again, it's like, you know, it's just a matter of looking at those things together. Okay, so again, but even the problem, the amount of magnesium bromide that remains is 7.6 grams of silver nitrate. It's silly, okay? Now the reaction yield there, that essentially the yield is easy because essentially you have side reactions and other things like that. Say, for example, you have a problem where you're supposed to get 63.2 grams of product and you end up with 56.5 grams of product. What happened to the other stuff? This is what you get. This is theory. What happened to the other stuff? An error. It might have spilled. Something may have happened in the reaction. It's cross reactions, etc. Okay, so that's just yield. And the percent yield here would be 56.5 divided by 63.2. Okay, times 100%. That will give you the percent yield. Okay, it's over the theoretical and whatever else. Now that's important in industrial chemistry, is figuring out what the yield of product is. Okay, so basically there. The theoretical yield is the amount that's calculated, can be obtained from the given amount of reactant. The actual yield is what you get. And usually it comes from spillage, it comes from other stuff, side reactions that might occur. And when you have side reactions, you're just kind of making it better. You're just kind of redoing it, etc. So basically that's that. The percent yield, you divide those two together. Now, silver bromide was prepared by reacting 200 grams of magnesium bromide with an adequate number of silver nitrate. What does that mean when it says adequate amount of silver nitrate? What does that mean? When it says, is this a limiting reactant question? No, it's not. So essentially you could assume you only need to do it once. So let's go through this product once with this. Determine the theoretical yield, do it the same way. Grams to moles to moles to grams, okay? So basically you're gonna have 200 grams of there. So you put the first number down. Then you have the moles, you convert it to moles. You then use the mole ratio, okay? 1 mole to 2 moles of product right there. And then you figure out how many grams. Now that's 408 grams. Now what is the percent yield to that? How would you calculate it? Right, very good. 375 divided by 408. This is the true yield. This is the theory, okay? Times 100%. And that's essentially that, okay? So we go to the next slide, show it in better handwriting. Percent yield, actual yield divided by theoretical times 100. They must have the same. Okay, hold on a minute. I'll get you back on the thing again. We got balanced again. Okay, so this is the percent yield for those of you who are distant. I'm going back on the slides. Okay, this is where I got the last one. You do the percent yield then, go to the next slide, calculate the percent yield. Actual yield divided by theoretical, have the same units. The percent yield will go in like that. That gives you 91.9%. Again, the end. Okay, can everybody hear me again? I did get to the end of the slides before it died on me. Do any of you have any questions? Anybody there have any questions of me? Okay, I'm going to share the screen again here. So we're next to the last part. Okay, I got to the end of the slide. So now what I'm going to do is go to the other thing with notes, just so we can go back to that one. Okay, basically this is the limiting reactant thing that I was talking about before. And basically he does not go through the steps as those other slides. So I do recommend when you're working, go through the other slides yourself this afternoon when you're working and when you're working on the problems. So kind of have the book open with you with the problems and work the problems while you have the other slides on your laptop or whatever else for the Hein. Okay. But this is essentially that with the limiting reactant. Percent composition and empirical formulas. The percent composition, that's the amount of the grams of each element in the material. And basically you have 84.1% carbon, 15.9% hydrogen. Determine the empirical formula. And basically this is just a matter of starting with, when you're doing this kind of problem, you start with the assumption that you have 100 grams of material. With this one, why do I start with the fact that I've got 100 grams of product? Why do I use that when it gives those percentages? What can I do there? Yeah, you could convert it to moles with that too. So essentially, we get 84.1 grams of carbon. And so then you have 12 grams of carbon is 1 mole. Okay, what does that number turn out to be? Please calculate it for me, somebody. Do you have a calculator? 12. 7.008. Okay, so essentially you have there. Now you have 15.9 grams of hydrogen. Okay, and it's 2 grams of hydrogen per mole of hydrogen. So how many moles of that is that? 15.9 divided by 2. What does that make? Okay, I'm gonna put you back on the screen again. I'm going through the other slides now. Okay, essentially we go there. I'm gonna delete this. The moles of carbon is 7.1 moles of carbon. The moles of hydrogen is 15.9, but we added it as a gas there. So you have the mole ratio between both of them. You need whole numbers, and essentially this shows you how this is done, where you take the 7 divided by 7 and then the other one and multiply by 4, and that gives C4H9. This is part of why I didn't use these slides. It's rather confusing for you. So I'd recommend even in this part, percent composition, this is in chapter 8 of Hein. So you can go back and get that from Hein too. But when you go to big numbers like this and get it, it kind of gets confusing, okay? So elemental analysis is just combustion and then mass spectrometry, and essentially we are done chapter 3, okay? So the quiz tomorrow will be basically on chapter 3, going all the way through limiting reactant, and I will start chapter 4 tomorrow. Our exam will be, our second exam will be a week from Monday. So keep that in mind regarding it. If we end up being a little slower for chapter 4, I'll delay it till later, but right now it looks like it'll be a week from Monday. Any questions? Yes.
Is percent yield gonna be on the quiz tomorrow?
Yeah. Yeah, and I'll keep it simple. I won't do anything complicated with that, okay? Those of you virtual, any questions that you have? Okay, we're done. Thank you very much. I'll see you folks tomorrow. I will send out an announcement. Those of you virtual, we'll try and have the quiz at 11 o'clock.